And recording. I see the time is 6:01. It is Thursday, March 8th, 2018. This is the regularly scheduled class meeting of ITSE 2309 at Preston Ridge Campus, Collin College. And let's see. Tonight we are in Module 7, I believe. I see I have quite a number of things there to grade. So I'll go to modules, and the last time we met, we were talking about data aggregation, chapter 5. Excuse me, we are in module 8, which is chapter 6 in the textbook, or subqueries. A fairly important chapter. Up until now, we have been looking at our select statements as the idea of joining tables, select from where, or we would join tables. So we could join a table with itself, or we could join two tables together and follow the primary key, foreign key link. Usually it'll be primary key, foreign key. It doesn't have to be, but that's usually the case. We talked about inner join and outer join. Outer join, which gives you all of the records, even unmatched ones from, typically speaking, we say one side or the other, because full outer join isn't used very much. Okay, so it's usually either a left or a right. Then we talked about data aggregation. In data aggregation, we have things like average, sum, minimum, maximum, let's see, min, max, sum, average, and count. We talked about the rules of data aggregation. If you have an aggregate function in the select line and something that is not aggregated, then you must group by the non-aggregate functions. For example, I can select vendor ID and the count of the vendor's invoices. I have to group by vendor ID, and then I will get the counts for each one. Okay. So now today we're going to be talking about subqueries. Subqueries have some interesting properties, and we're going to talk about them here. Let's look at a task that's really good for that. Find the invoice IDs, possibly plural, maybe it's one, maybe it's more than one, that have the maximum invoice total. So the maximum of the invoice total is one number. It's the maximum, but there may be two, maybe one, there's one or more records that satisfy that. We don't know that it's just one. We could have ties for the maximum, and I believe I put in a pair of ties there. So when we execute this query, I order by invoice total descending, so the two that are, let me see if I can select them here. The two that are tied are right there at the top. So I know I have two that are tied. I have invoice ID 2 and invoice ID 39, both tied for invoice total of 37,000, whatever it is, rounded to 38. It's a pretty good sized invoice. So I have two of them with exactly the same max. If it were a penny off, it wouldn't be, but yours probably won't do that because I kludged my data. I went in and I put a pair in there so I'd have something to find. Now, most of the time, it's not really wrong, so far anyway, to return extra fields. If you want to throw in an extra field and just for test purposes to see if you got it, you know, it's okay. For example, find where the invoice total is null. Well, all you're going to see is nulls in there. If you want to print that just for fun of it, go ahead. There's nothing wrong with, at this point, returning anything extra in an extra field, but we don't want to return extra rows. If you want to return extra columns, we'll filter them out later. But extra rows, we don't want. Okay, so this guy has extra rows. I'm saying, hey, I've shown you the maximum. I sorted it descending order. Therefore, the ones you want are the two at the very top, or three at the very top. Okay, so you can see it okay, but I want to get rid of the extras. I'm thirsty tonight. Okay. First thing that comes to my mind is I would try this. I know how to do group by, so I'm going to try this. Select invoice ID, max invoice total as something from invoices, group by invoice ID and the invoice total, having invoice total is equal to max invoice total. Now, that will run okay. It's syntactically correct. But notice that I get the maximum invoice total for each invoice ID. So I get every invoice ID. Because what is the invoice totals when I'm grouping by invoice total? I'm grouping by invoice ID and invoice total. That means I have I have one invoice total for each invoice ID, and that's the max. So I just get everything back. It doesn't do what I want it to do, and it's not working. It's semantically wrong. I mean, what I'm getting isn't the rows that I want. I only want 2 rows. Here we have the subquery. Okay, that's what this is about. And some things, this is one of them. Find the minimum, find the maximum, find something. Now, where a subquery is really great is where everything you want comes from one table. Whenever that's the case, it is meat for a subquery. I could do this in a join. I can do it, but it's far better to do it in a subquery. Select. Now let's look at how this logic works. Give me the invoice ID and the invoice total from invoices. One table, don't have any aggregate functions in there. Where the invoice total is in the set returned by select max invoice total from invoices. Take a look at that. At this query, take a look at the, it's usually best if you start here and say, what does this return? One number. Now I want the ID and the invoice total where the invoice total is in that one, in the max. Does that make sense? Questions? Let's see, for people attending in the, I'm going to turn on the, I'm going to put my messages up on the other screen. Okay, for you, those of you attending in Internet land, if you have any questions, go ahead and send me a question via Canvas messaging. I have the screen up where I can see it, and I'll be keeping my eyes on it. But this is the one that works. Now, if I execute this one, notice I just get the 2 invoices that I wanted. I get invoice ID number 2 and invoice ID number 39. Are the 2 that have that maximum value. I could have said the minimum value. I say, you know, show me the ones with the minimum value, and it would show me all that had that. Okay. Now this does not show me any. Well, there's lots of things I can do with a subselect. Now I'll tell you this. I do the subselect after the table joins because that's the order that it comes in our textbook. But when I am writing SQL, the first thing I think of is a subselect. I go for a subselect before a table join. And most of the time, Most of the time, I can write my table joins as a subselect if I choose to. There is no particular advantage to one over the other. Some people, yours truly included, think that a subselect is more intuitive than a table join. Because first I go through and I find the maximum. So how would the system do this logically anyway? Go through everything, find the maximum of the invoice total, now go back through it again and find the invoice IDs where that is satisfied, which is the same thing it would have to do in a table join. There's no particular saving, and the system is free to turn your subselect into a join or vice versa if it wants to. So the runtime support system will make its own decisions about how it answers your query. Okay, questions? Okay, we'll come back to that one in a minute. Do you remember our childless parent query? How do I know it's a childless parent query? Well, it says so. Second, it's an outer join. It is a left outer join. What do we have on the left side? I have the vendors table, invoices. Take everything from the vendors. I know that the vendors is the parent table. And sometimes people about this point in the class, they will say, well, how do you know that? How do you know that? We learned it by studying the tables. That you can't just walk up to a database and start writing queries against it. You have to know how that thing's put together, and that means you have to spend some time studying it and getting familiar with it. If you don't know what your parent keys are and foreign keys are, there's nothing much you can do with the database with respect to SQL. You have to know that stuff. So you have ways of finding out by looking at the database diagrams, and we'll talk more about that. But right now, we know that because we've been studying it. We've been working with invoices and vendors. So I know that the vendors is the parent and the invoices is the foreign key child. And it says left outer join. That means I'm going to take everything from vendors and that doesn't have any children. So I have a left outer join here. This says, show me the parents, show me the vendors that have no invoices. And I believe when I execute this, I get 89 rows, I believe, yes. In fact, I have more invoices in there that don't have more vendors with no invoices than I have vendors that have invoices. That's okay. That's the way the data run. Okay, I can write this same query. If you don't like a left outer join or an outer join in general, you can write this one as a subselect. And the reason this one lends itself very well to a subselect is because everything you need on the output comes from one table. Output comes from one table. The only reason that I even needed the invoices table at all was to find the ones that are in the vendors table and are not in the invoices table. Therefore, it has to be in the outer join. I can't answer it by only looking at the vendors table, but all of my output comes from one table. Anytime I'm in that situation, you're talking, for me, I'm going to go straight to a subquery. Because to me, it is more intuitive. If you look at it, now I know that this, when I say left outer join, that means that I want everything from the left table and matching rows from the right. And then the where clause throws out the matching ones. Okay. Here is the same query written as a subselect. Notice that this one does not have a table join, but it is a table join. Whether you think it is or not, we go through here and we get a list of all the vendor IDs from invoices. Now go through the vendors and find the vendor IDs where that vendor ID is not in there. is, in my opinion, that's more intuitive. That is essentially an outer join. No, it's not an outer join. I shouldn't say that. It's a subquery. But it arrives at the same answer as the outer join. Sure. What? Scroll up, why? Oh yeah. Uh-huh. Question is, will I scroll so that they can compare them? They are the same. They are the same. The same output, the same query. One of them will give you the childless parent. They both give you the childless parents. One of them is done as a left outer join. The other one is done as the subquery. Do you happen to agree with me that the subquery is perhaps more intuitive? Of course you agree with your teacher. I mean, everybody agrees with your teacher. Yeah, sit there, bobblehead. Okay, they are the same. The top one says, the property of the left outer join is it gives you everything from the left table, matching rows from the right table. And then the where clause throws out the matching rows from the right table. So this one only gives me the unmatched. It's fairly typical. And so there's the, okay. Most of the time, most of the queries that we wrote, most of the joins, I can write as a subselect. Where I would not tend to write it as a subselect, I would stick with the join, is when I have data, when I'm selecting data for output that come from both tables. In that case, a subselect tends to be more tedious. You say what? If I change this and instead of, let's see, I want to see the vendor name and the invoice ID. Okay, if I change this to vendor name, invoice ID. Now, for the nulls where I don't have a match, I'm just going to have a null invoice ID. But if I want vendor name and invoice ID, now I'm taking something from vendors table and something from the invoices table. That does not lend itself as well to a subquery. Where it lends itself to a subquery, notice that in this outer query, I just have, it's a much simpler query. I'm only getting output from one table. Down in the subquery, I'm referencing the invoices. I can't see this from the select line. I can't see down into that other subselect. And we're going to find that we have scoping rules just like we did in those of you who have taken the C programming language or any programming language, Java, where you have the scope of a variable. Where can you see a variable? Well, we have that kind of thing happening in SQL also, just when you thought you were safe. In fact, I'm going to play around a little bit with a variable today, even though it does not really come into this class. Using a subquery to find invalid parents. Here is the same thing, invoice ID, vendor ID from invoices. Everything, the output of the query all comes from the invoices table. Where vendor ID is not in, select vendor ID from vendors. So this would be a, the right side of it, the upstream side. I want everything from the invoice ID table, matching records from the vendors, and then I filter out the matching records. So this would be a, let's see if I can get this. Select, what am I selecting? on where is that right? Is that going to give me my invalid parents? Yep, there's just one of them. So this is invalid parents. So here it is as a right outer join. I want everything from invoices and just the matching ones from vendors, and then this filters out the matching ones. So the only thing I'm going to see is the invalid vendor ID. Invoice number 68 has an invalid vendor because I put it there. I knew it was there. But if I were searching for that, this is going to be something you do quite a bit when you're trying to troubleshoot tables, because what you frequently will do is you turn off the foreign key. If you're doing a lot of inserting, you can disable the foreign key and just hope everybody types it correctly. And then they won't. So you go back in with the outer join and you find the ones that where the typist fat fingered it, and they get special high intensity training, and you found your problem. Now you go fix it. If you turn off the foreign keys for lots of inserting, you will find that your inserts will go a whole lot faster. Okay, I don't see any. Are there any questions so far? Again, people on the internet. Okay. I see, the way I see it is everything's okay with my audio. Questions so far, we've seen a fairly simple where the table or the query, the subquery appears in the from line. Okay, in the where line, excuse me. So select something from usually one table. Now we can have a join there. But then where, the where clause has another query in it. So it's usually I have an in there where some value is in this set. Lots of it is select maximum, select minimum, select count. So show me all of the invoices where they have the greatest number of invoices, and I might have ties. So when you want to find the greatest and the smallest in a table, and you might have lots of ties for it, you're not guaranteed that I'm only going to have one of them that is the minimum or one of them that is the maximum. I might have several tying for it, and that's a fairly tricky job to do. If you've done array processing in C++ class, finding the winners plural of something, the highest values, where you have to have several of them, gets very tricky. Now I can find the one that's the maximum fairly easily. If I just ignore duplicates, just give you the first one I find, that's fairly easy. But finding all of them gets tricky. And the easiest way to do that is with the subquery. Okay. Observation, Eric, you look like you have something right on the tip of your tongue. No. It's not that hard. Go ahead. Okay. I'm going to talk now for something different. Okay, up until now, we have the subquery has been something like this, where vendor ID is in, vendor ID is not in, and I'm going to make the case using in. You will see a lot of people will write equal sign there, where vendor ID equals or does not equal. They'll use the does not equal or equal to. I'm going to argue against that in just a moment. It will work. So you will see if I were to change this to a not equal, we're going to see that this will work. Okay, I guess it won't. It used to work. I think logically it's a good thing that it doesn't. We should not use equals. I think equal to works. One equal. I think the equal will work. Nope. Oh, good. Okay, anyway, the bottom line, what I'm trying to get to there is where the vendor ID is not in, select vendor ID from vendors. Okay. Oh, it will work if you say select max and there's only one value in there. The equal to will work, but I'm going to argue against it anyway. All right, so here the subquery, the inner query, is in the where line. To me, that's the most intuitive. I like them when that happens. It doesn't have to be in the where line. Remember, a query returns a table. This is called a derived table. In the from line, I can have a subquery that appears in the from line also, because I select from a table. So look at that one. The subquery in this one, the outer query selects vendor name MyMax from a subquery. Now, notice that the subquery names max payment total, MyMax. This name right here is visible. From out here, I can see that name because it's in the select line, because it's selected. It's part of the output of that query. Therefore, I can use that name in the select line. I can use this name that got where it got renamed and passed up. So I'm selecting it, therefore I use it. This is why if I didn't name this, I would not be able to select it. Select vendor name, max, from vendors, enter, join. What am I doing here? Select vendor name max as my max from, okay, so this is giving me the greatest one, grouping by vendor ID. So for each vendor ID, I want the maximum vendor. And this one, the nice thing about these is that I can run it, just this part of it, okay? And I can execute. Notice that I got an answer. I got 33 rows. Okay. I have to use the vendor ID because the vendors is joining, now we have reached a point where we might be talking about security. The vendor ID could be like a social security number. It could be confidential. And it is not always okay just to add extra fields to the output if that would violate the security of something. So we have to be able to block that also. And we have to be able to say, no, now I haven't made a big deal out of it. In fact, I've said, oh, it's okay. If you want to throw in a few extra fields, go ahead. In this case, we need to not have those fields available as output to the user. So I'm going to block them by hiding them down in the subquery. So the vendor ID is down here. I have to group by the vendor ID because I don't know that the vendor name is unique. Maybe it is. It probably is. It is in our data set. But how do I know that in my millions and millions of records out there, the vendor name is unique? I don't. I know that the vendor ID is unique because I made it that way. It's primary key. The vendor name may or may not be. We span states. We're all over the United States. How do I know that I won't have something else named Collin College in a different state? I don't have any way of knowing that. So I have to select and group by the vendor ID, but I do not want to output the vendor ID. So from this, I can hide that, and I have the derived table inside of here. Now, when I execute this, I still get 33 rows. I only get this subset of them. Now, why would I need to hide the vendor ID? I don't know. It could be a social security number. And this could be being displayed out on the web. This particular one would be secure because that information, the vendor ID, is not in the query at all. It is hidden down here. I could select it if I were to name it. If I put an as on it, but I didn't put as. I have no way of talking about V. V is hidden. The vendors table, I can't see the vendors table at all from the outer query. I can't see the invoices table. One other point here, notice that I renamed this. So from, notice I must alias that table. Okay. So if I have a query in the from line, then I must alias it. I call it D for derived table. But I typically, when I alias a table, I do so because I don't like typing. Therefore, I tend to, when I alias things, I tend to use very terse, short names. The only thing I care about this as, I just want to pass that name up, and I want to use that name up there. I'm going to keep that name as short as I can. In SQL, remember, we can put spaces and stuff like that in our aliases by putting them in square brackets. I have never done that in my life. I don't care. If it needs spaces in the name that we're going to call it by for cosmetic purposes, they can get put on later at a higher level. Let the web developer put the spaces in there. From me, they're going to get the same names that they are in the database, or something very terse. Okay. And talk a little bit more about that here in a minute. What time are we? Okay, we have time. Questions on this derived table. The derived table is just simply, here we have a subquery. The subquery is in the where clause, the simplest one. And as we go to, if we put the subquery in the from clause, it is called a derived table, or let's put it this way, our textbook calls it a derived table. That's not common. You won't hear it called everywhere that, but I don't know if you Googled derived table, whether you'd see that used commonly or not, but that's the first time I just always called it a subselect in the from line. So subselects can go in the where line, they can go in the from line. Can't have a subselect in the select line. Well, I guess I could. Okay. Two places they can go in the from line. When you have a derived table, when I have that table, what's his name? What's the name of this thing right here? Its name is D. D can participate in a table join. D can participate in anything, inner join, outer join, so you can get fairly complicated with it here. I'm just showing you a simple version of it. Derived tables, because if I put it down in the where line, I don't have that table. I can alias it here if I want to, but what's the point? Because it's in the where line. If I put an alias on it here, I think that I'm getting a red mark on it, so apparently it doesn't like it. So I guess I can't, but even if I could, it wouldn't make any sense. What would be the point? I can't use it there. Okay. So I'm actually creating another table. This is a temporary table that is going to run, and it's going to come back, and it's going to exist for just a millisecond or so, and it has to have a name. So you have to give it a name. You must alias this guy. If you don't alias this, you will get, for your reading pleasure, look, I'm starting to get red lines on there. And it's saying, wait a minute, something's wrong. What's wrong is I failed to give the table a name, the derived table. So it must have a name. That's one of my favorite mistakes to make, forgetting to alias a derived table. Questions at this point? I see no questions from internet. Okay. Let's see, 6:40. The Big Bear. What exactly did, I'm trying to see why I correlated subqueries. Let me see what this, by the way, I highly recommend Dr. King's video. Now, Dr. King and I don't see eye to eye on a few things about syntax. For example, he drops the as, he drops the joins, but he is also teaching a higher level class. So he's teaching at a university, and I believe it's offered as a junior level class, upper division class there. It's still about the same level, but he's dealing with students who do a lot more who have had a lot more programming than you guys have necessarily had. And if I were teaching a class at the junior level where I knew everybody had a course in C or Java, then I might feel comfortable dropping some of the syntax. Let's see, what's she doing? Let's see, please review. Consider a variation, finding vendor ID with the greatest invoice total. So we've seen that. Find the vendor ID with the greatest invoice total. Now let's change it, and I want each vendor ID and the greatest invoice total for that particular vendor. Okay, so for each vendor, I want the max. Now, not sure I should be able to do this with a group by. Anyway, let's look at it here. The thing that makes this a correlated subquery, I don't know that this particular example has to be done using a correlated subquery. Something is bothering me about that as I look at that, I'm saying, wait a minute, I could do this. I think I could do this with a group by. But let's do it this way anyway. The thing that makes a correlated subquery is that the same table appears in both places. So essentially, it is joining the table with itself, and we have seen a self join before. It's joining the table with itself. A correlated subquery, you have the same table in both the inner query and the outer query. So notice that the invoices is from in the outer query, in the from line of the outer query, and it's aliased up there as invoice out, INV outside. Then I have the same table in the inner query, and it's invoiced in the, it's aliased there as invoice inside. So I've got inside and outside. So INV inside is its name down here. INV outside is its name up here. And just like in Java or C or any language, I can look out. I can look out and I can see variables in the outside scope. So if I were talking about that in here and I were looking for Eric, I'm going to find him here, right? But if I were looking for Ezekiel, I can't find him or her, I guess, him in here, so I would go outside and I would look up and down and search in the halls, and I would search outside, so I would keep going outside, but I can never go inside of another room to search. So in general, that's the way variables are resolved. You go outside of the scope and look out there. Now, I find when I'm talking about this one, INV inside, when I'm talking about that table, I'm talking about this one. I find it right there. No problem. When I talk about this table, INV outside, I go up here and I find it in the next level up. That is what makes it a correlated subquery. I don't know that I have to do it this way for this one. I think I could have used a group by here and it would probably have been better. The system is free to change it. All it has to do is give me the same answer. So notice I don't have a group by here, even though, well, yes, I do. I have to group by vendor ID because I have to meet that rule right there. This is an example of a correlated subquery, but I'm not sure that I have to do it that way. I think if I just didn't have this, I'm not sure this subquery is doing anything for us here. It was an example that was given in the textbook, and I just grabbed it and copied it, and I should have looked at it a little more closely. But I don't think it's really doing anything for us. But this is an example of a correlated subquery. The reason it's a correlated subquery is I have invoices, the same table used in the inner query and the outer query, and this is the important part. This is what makes it correlated right there. I'm referencing the subquery in the where clause of the subquery references both tables. So it's like a self-join. Questions? I'll bet there are a few here. Something was bothering me about that one when I was writing it. I think I could have done that one with just a group by. I'm going to have to rewrite that example. Let's look at a different example. As any other vendor. Find vendors who live in the same city as, I'm going to say, at least one. At least one other vendor. Okay? So now I could do this with a count. Let's see, could I do this? I could display the cities that had a count greater than 1, and I could work at it that way. So essentially, that's what happens. I'm searching for the vendor names. Let's see, searching for vendor names where the count of the vendor city is greater than 1. Grouping by. I think I could do it, but this is a pretty good example. This one is a good example of it. Select V1 vendor city, vendor name, vendor city from vendors as V1. Now, I don't think I had to have V1 here because I can't see V2. I can't see this other one. So I think I'm going to take that off just to show that I don't really need that. I can say vendor city, and it will be this one. But it doesn't hurt to have it on there. Typically you will, but in this case you don't, because this outside one cannot look inside. It can't see V2. Now down here, select v2.vendorcity. Down here, it definitely has to be there. Select vendor city from vendors as V2, where V1 vendor city is equal to V2 vendor city. Now, if I do this, I'm going to get that I live in the same city as I live in. Okay, so if I were talking about people and I want to find people who live in the same city as any other person in the classroom, well, I live in Denton and I live in the same city as I live in, so I'm going to be in both queries. Therefore, I'm going to get returned even though I'm only one person. Anybody else live in Denton? No, so I would still get returned. Okay, but I'm looking for, if 2 people live in Frisco, I want to see those people. If 3 people live in Frisco, but I don't want to see people who just live in a city by themselves. You with me? Therefore, I say, and v1.vendor ID does not equal v2 vendor ID. So that stops a person from matching, that stops the vendor name from matching itself. If I didn't have that one on there, I would get all of them. But I only want to see pairs or triplets. Let's see what the output is here. Then I'm ordering by vendor city. And let's take a peeky. Can we see this okay? Or do I need to drop it into Excel? Blow it up? Yes, drop it into Excel. Okay, or you can run it. Notice that I have Anaheim, Anaheim, and then 3 of them, Boston, 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 Chicago, Chicago. Everything has at least 2. My goodness gracious, I have just a whole bunch of Fresnos. How many Fresnos? A whole bunch of them, whole page full of Fresnos. That's where we live, by the way. Los Angeles, Pasadena, Philadelphia, PA, Phoenix, Sacramento, and Washington, D.C. Now, let's go back again. It's not so much, I'm not too worried about the output of that, but what is it that makes this a correlated subquery? There were other ways I could have done this, and many times there are. Could have joined the table with itself and gotten it, yes. I could have done a group by and count, yes. Group by, could have grouped by vendor name, count of vendor cities. I mean, there's other ways, yes. What is it that makes this a correlated subquery? Okay, you know that you have, you do something like this. There's other ways to do it. You can join the table with itself. And that's probably how I would do it. I mean, if I didn't have a correlated subquery, I would join the table with itself. And I can see if we can show that. From vendors V1, vendors as V2. Let's see, I want to join. Equals V. Now I have to have the V1 dot on that vendor name because now they're both visible. From vendors as V1, inner join vendors as V2. Why is it complaining about that? I don't see what it's why it's doing the red line there. I'm going to try running it and see what happens. Problem with vendors as V1. What's the problem with that? On. On. I'm trying to use the old syntax. This one would be a where, I think. Let's see if this gives it to me. I'm getting a lot of duplicates in here. I'm getting the right information. I think if I change this from a not equal to less than, I think it will probably work. National. I'm getting a lot of duplicates. I'm going to have to work with that one. Over the break, I'll see if I can get this one down. This is a join with itself, but we have a correlated subquery when I have vendors or some table in the outer join, and it's aliased. I have the same table in the inner join, and it's aliased, and the where clause references both tables. So it's qualifying the rows based on both tables. I can see both tables, therefore I have them joined. Let's see, it is 6:56. I'm going to pause the recording. I don't see any messages. So let me. Okay, resuming the recording now. here I have, let's go back to the, if I, probably blown your minds with the correlated subquery. That's the point of this where students have the most trouble. Correlated subqueries. How do I know it's a correlated subquery? I have the same table in the outer query and the inner query, and the inner query references it. References both of them. I would use a correlated subquery essentially when I would use a self-join, when I would join a table with itself. So, for example, if I wanted to find supervisor, if I had a table, I think a good example would be a table of all employees. And I have a field called supervisor that references the same table. So it's a self-referencing foreign key. It references the same table. So the employee's name references the supervisor. So it references another employee's primary key. My supervisor is a primary key of somebody else in the table. Gets a little tricky when excuse me, the top level supervisor, who is their supervisor if I require it. That would be a correlated subquery if I wanted to show those pairs, and I might give that as an example next time. I think I'll probably come back to this once, at least the correlated subqueries. I would like to do a few more good examples of those. I'll try to get those ready over spring break. Okay, let's go back now to the simpler part of it. And this one I like these subqueries. Everything comes from one table. Ooh, all of my output comes from one table. That's meat for a subquery. And I'm comparing it to the average. So do I have anybody who's average? Average. Well, the average person has what? 2.7 children. You can't have 2.7 children, okay? And 1.3 cars or something like that. I'm making up those numbers. But the problem with it is that you will very seldom find anybody who is average. So it isn't going to surprise me a bit if I find that there is nobody, that there are no records who has an average invoice total. Now, if I want to, I can find out what it is. Here's the nice thing about a subquery. I can just highlight that subquery and run it by itself, and I see it's $2,212.43. Okay. That's the average invoice total. But I don't have anyone with that. And moreover, if I put that in there, into the table, trying to find one, it would change the average of the table. So it'd be like trying to catch a fish in the water. You know, you can't catch a fish underwater. What we will usually do in this case, how close to average do I have to be before you're going to let me call myself average? Okay, so I'm average guy. What does that mean? How close to average? I've got an average grade. How close to average do I have to be? I probably won't be exactly average. And this is a problem that you run into. And lots of times you run into things like standard deviations here. And, well, are you within the first standard deviation? Those of you, how many of you have had statistics? Oh, fun, huh? I like statistics. Oh well, okay. I won't argue with you. We won't argue. Okay, how close do I have to be before you're going to let me to the invoice total. How close does it have to be? Now, this is outside of this class. So if you don't pick this up, that's okay. This is the next class. Now, in SQL, we have SQL. Okay, so on an SQL platform, we have SQL. SQL is supposed to be the same across all platforms. Oracle SQL, you're supposed to be able to pick it up and drop it right into Microsoft SQL, Microsoft SQL Server, and it is supposed to run without any problems. Good luck on that one. It's supposed to. Yeah, air quotes on the supposed to, because I can almost assure you that you're going to have to tweak a few things about it. But in general, the logic of it, when you write a correlated subquery in Oracle and a correlated subquery in SQL Server are exactly the same thing. The syntax of the inner join, the syntax of the outer join are supposed to be exactly the same. But when you get much beyond that, it won't be. Around SQL, now SQL is the common thread, the common core. Around SQL is wrapped another programming language. What are we missing in our programming language SQL? Well, we don't have if then else. We don't ever have variables. We don't have while loops. Don't even think about a for loop. And printing, we can't print something to the screen. But in this language that is wrapped around SQL is all of that stuff. We can have variables. And so I'm just briefly going to touch on that, and that's where that term Go comes in. Okay, so we've seen Go use it. I say, well, you can use it. I used it when I created tables. So I create a table, I say go, then I create tables, and then at the end of creating tables, I say go. And some people say, well, I think I'm going to put one in between each table creation, and it works just fine. Okay. We're going to see when we start creating stuff later that there will come a time when I will have to have go. Here's one. When I declare a variable, I have to have go. But we don't declare variables in this textbook until we get up about chapter 15, which is the next class. But here it is. Declare. Now we have to have a go. Go. Go says start a new script. Finish all that stuff up there, start a new script. Okay. Here inside of this block, we're going to declare, and the name of the variable is delta. Means how much can it change? How wide of a gap will you let me have? And I'm going to say it's $75. So if I'm within $75 of average, is that going to be close enough to where you'll let me say I'm average? I mean, the average is 2,000. So if I can get within $75 of that, am I average enough? And if I make it larger, then I'm going to get more people. If I make it smaller, I'll get fewer people. I'm going to say $75 because I tested it and I'll get a couple. Then set, you can also use select, but set delta is equal to $75 because it's money. So declaring, I have the word declare. The variables in SQL Server, local variables always begin with a @ sign. And then they're declared, I have to tell you what they are, what kind of a thing is it. So this is just like declaring a variable in C. Excuse me. Excuse me, I need to get a drink of water. Same idea as any other language. Okay, now since I have declared this variable, I can use this variable, select invoice ID, invoice total from invoices where invoice total, all right, is greater than any. Now, I want to talk about this any. any and all. How many how many values will I return from this select statement? Only one average. So average minus delta will be the average minus 75. So where it is greater than the average minus delta, this is just one number. By the way, I don't have to alias this. It really doesn't, there's no particular reason I need to one way or the other. Whether you do or you don't, it's fine. Okay. What is this? Answer is a number, a value. Actually, it's an integer that is represented as four. It's assumed to represent 4 decimal places, but anytime you fix the decimal places, it's an integer. You fix those decimal places and you say that's always there. I say fine, it's an integer. I just shift them out and shift them back in when I show it to you. What is this on this side of the greater than? What is this? That's a select statement. What is a select statement? A select statement is a table. Does it make sense to say, is this number greater than this table? Now, the table just has one row, one column, one value. But there is a type mismatch there. Because the thing on one side of that greater than, could be an equal sign too, by the way, is not the same type of a thing as on the other side. So I'm comparing a number to a table. And we used to do that all the time. It would only work if the table had exactly one value in it. One row, one column, one value. Okay. So it would work. So if I took that out, now in the later standard, we have the words any and all in there. And it is better always to use one of them. Now, if you just have one value in there, does it make any difference whether I say it's greater than anything in there? Well, there's only one thing in there. Or it's greater than everything in there. There's still only one thing in there. Either way, you're going to get the same thing. So it doesn't really matter. Use one. I generally will use any. Just why? I don't know. I just type, that's what I type. I do not like it to just say greater than, even though if I did so, it would not have a problem with it. It would say greater than because it would recognize that there's only one thing in there. It would work. If there were more than one thing in there, then I would need to say it's greater than anything that's in there. So is there at least one value that's greater than? Or the other side is all. Most of the time, when you use it like this, you like it when there's only one value. In that case, it doesn't matter. If you just have one value, use either any or all. It really doesn't matter, but use one of them. Am I making any sense, Kathy? Oh, yeah. Okay, let's look at what this subquery does. Where invoice total is greater than the average minus delta, and the invoice total is less than the average plus delta. I could have said between. I could have said between. Okay. And it would have worked. I don't write between very often. I usually like to have more control over it than that. So I will usually, if I mean greater than or equal to or greater than, if I If I wrote between, it would be greater than or equal to. I could where invoice total between this one and this one. But I like this better because I'm saying greater than anything in there, but there's only one thing in there. Or maybe I would say greater than all of them. There's still only one thing in there. Either way, you get the same answer. Questions. And when I execute this, I have to remember to execute the, when you execute and you have a variable in there, you have to remember to execute that variable or it won't happen. Once that finishes executing, that variable goes away. And if I try to do it a second time, I don't think it's going to work. Might. Notice I got two of them. I got invoice ID 51 and 79 are both within $75 of average. If I want to make the delta a little bit larger, I can get a few more. Push it up to $100, I think I get 4 or 5. Are there questions? Okay. This part right here that says that the declare is not a part of this class. I'm just pointing out that, yes, you have variables, and I can say, you know, something like if delta is greater than 50, then do something else, do something different. I can take the variable, I can take a value out of the database, put it into variables for processing, and process through the database using a while loop, although that's considered not very good because the database will almost always outrun what you can write. Anytime you can stay in SQL, you're a lot better off. But something like this would be a good place for a variable, because particularly if I'm going to use delta in several places later, that's the range I'm willing to accept, from plus $75 to minus $75. In that range, I'm going to call you average. Okay. Making any sense? Here's an example of the max or the min or whatever. This particular one goes back to, this was the one I had at first. And notice that this one is using the equal to instead of in. Never use equal to, always use in. Never use greater than or less than in a subquery kind of a situation, right? So if I want where the subtotal is equal to some number, yeah, I can where it's equal to 10, that's fine. But where it's equal to the max or the minimum, do not use equal to. Will it work? Yes. Yes, it will work. In my opinion, it shouldn't, because it is a type mismatch. I have a number on one side and a table on the other side. The table happens to have one row, one column, one value in it. Therefore, it works. But it's not the same thing, because a number is not the same thing as a table that has a number in it. Okay. Use in. In is logically correct. Is it in that set? Not only that, that if you use the in operation, the in will work, does not have to just have one number. If you select something that has, if you're selecting multiple values here to check it against. Okay. We are going to spend a little more time on this. Always use in. And anytime you're using greater than or less than, use either any or all with it. Greater than any, greater than all in that set. Yeah. Say again? Okay, when do they have the same meaning? They have the same meaning when this subselect will give you one value. If the subselect gives you one value, then you can just say greater than, but don't. Okay, they are the same when it is one. If I say select and I have something in there that selects a range of them, I will try to get that for next class period. I will try to have some examples of that, where if it selects a range of things, and I say I want it where something is in there, then I will have to say either any or all. If I just have one value, they're both the same. So SQL Server will let you drop it, but don't use one of them. Okay. Similarly, if I just have one value, max is just one value, it will let you get away with putting an equal sign there. Don't use in instead. Always use in with the set. Greater than any, or perhaps greater than all. Okay. Greater than or equal to works. But anytime we're comparing, we want to compare the same thing, because when I say any, now they're the same. So if is 3 greater than anything in this set is a logically correct statement, because I'm talking about each piece of it now. So the statement is now logically correct. Okay. Again, here it will work with just greater than, because average. So this says find the invoice ID, invoice total from invoices where invoice total is greater than the average. This one's kind of interesting. If I just select the invoice ID and invoice total, let me execute it. Notice that I have 114 rows. But when I select that one that is greater than the average, I only get 16 rows. What does that tell you about the data? I mean, it's okay. I have 114 rows in the table, but only 16 of those are above average. Invoices, I don't think I have any nulls in the invoice total. A lot of very high values in there. So there's 16 of them. I have probably actually I have a lot of very small values in there, and therefore the very large values are dominating. So the average is around $2,200 or so, and if you sorted them by you'd find that where the average falls in there, you have a lot more that are a lot higher number of them that are below average than above average. Ones that are above average are really above average. Okay, that's okay. You find that stuff in your data. Databases are very good for running statistics. They have they're very powerful. There are databases that are set up for statistics. Just the average database is not really a math engine. Some of them are set up with more. Oracle, for example, is a very high-powered statistics. I don't know much about what SQL Server does with statistics. Usually, if I'm going to do statistics, I would prefer to be over in a spreadsheet or with a statistical package like SPSS or something. I think that's what I've got cut out for tonight to 7:30. Are there any questions? Do I have any questions in my inbox? I see no questions in my inbox. Let's see. Kalkidan. Do you have anything you want to ask?
No, I
got to put on my headset. Any questions?
No, I don't have any questions.
Okay. Well, I'll be, I'm going to end the recording now. And I'll still be online if I'll just be checking the inbox. So if you need to get my attention or you want to ask anything, you can just send me a message in Canvas, and I will. I've got it up on another channel here. Okay, I'm gonna turn your mic off. Okay, I'm now ending the recording.